Move on to example number 2. Ready? So now example number 2 is a repeat of example number 1. But we're given the function y is equal to x squared plus 2x plus 3. Okay? All right. So,
Plus 3, right?
Plus 3. So, remember that y is equal to ax squared. We're talking about the standard form today, plus bx plus c. So that means there's an implied 1 there. We don't write it down. How many x squareds do I have? 1. Right? So then I know that a is equal to 1. What's my b term? B is equal to 2. What's my c term? 3. So that's the first step. Make sure that it's written in ax squared plus bx plus c. Now somewhere in homework they switch the order of it. You might have like 4x plus 2x squared. Remember that a is the coefficient of the x squared term. B is the coefficient of the x to the first power, and c is just a constant number with no x at all. Okay? If you do not see any of these terms, then the a, b, or c may be equal to 0. Does that make sense? Okay. So now, the first step to graphing this thing is identifying a, b, and c. And we have to make sure it's written in this order. So a is 1, b is 2, c is 3. The next thing we want to do is we want to figure out the line of symmetry. So the line of symmetry is negative b all over 2a, or negative 2 over 2 times a, which is 1, which is just negative 2 over 2, which is negative 1. In other words, x equals negative 1 is my line of symmetry, or axis of symmetry is how the book writes it. Okay? Next, I want to find the vertex. So to find the vertex of this thing, I know that the x value is negative 1 because the vertex x value is on the line of symmetry. That's where the line of symmetry cuts right through the vertex. So now to find the corresponding y value, I have to evaluate my function at negative 1. In other words, I'm going to take this function right here, I'm going to say y is equal to negative 1 squared plus 2 times negative 1 plus 3. So I'm just taking this equation, and wherever there's an x, I'm substituting negative 1 in for the x. Now before I move any further, does that make sense?
Yes.
I'm trying to find, this is the y value of the vertex. So I need the x comma y of the vertex. I know what the x is because I solved it right here. Good job. Okay? So now, negative 1 squared is just positive 1. 2 times negative 1 is negative 2. And then I have plus 3. So 1 minus 2 is negative 1 plus 3 is a positive 2. So that means that my vertex occurs at negative 1 comma 2. All right, does that make sense? Am I doing good so far?
Yeah.
By the way,
Hey, it's actually 0.
yeah, you made a mistake. Double check work.
Negative 1, it says negative 1 squared.
Huh?
Did you put negative 1 in parentheses and square?
No.
What's negative 1 times negative 1?
1. Negatives cancel out. I don't
Yeah.
know.
Common mistake.
You have to put the negative.
Everybody makes it, except
Classic
me.
Mike.
Shh, no names. So now, we know where the vertex is. The only thing we have left to do is this is a parabolic shape. We need to know if it opens up or down. Does anybody in this room know how to tell that? Yeah? Well, good for you. Does anybody else know?
Oh yeah, how to do it? Wait, can you repeat the
How can we determine if this opens up or down?
The C
negative
is
on
plus.
the
It
Wait,
not
opens up.
It's not the C.
Negative.
Plug it in.
It
opens up, but no, it's not.
If what is negative?
The
The
one
vertex
that says x squared.
Yeah, the
Which
number
is the
in front
one
of the
term.
x squared, which is the a term,
A.
right?
A.
So tell me what it is. It's
Oh.
1, so that's positive. So what does that mean?
Opens up.
So this is going to open up
Oh, okay, I get it now.
because a equals 1. There's one little extra bit of information that might be helpful to us. Does anybody know what it is? Yeah, you could say that, but I'm talking about just looking at the equation. That's a true statement, right? What?
The line of
The
symmetry.
plus 3 tells us where y intersects.
Very good. The plus 3 is the y-intercept. This means that when I plug in 0 for x, these terms kind of go away, and I'm left with positive 3. So the c term is always the y-intercept. So now if I go to graph this thing, does everybody have this written down?
Yeah.
All right. Wait.
So I'm gonna go ahead real quick.
That's good. No, you're good. You're good.
All right. So now what I'm gonna do is let's graph this thing fairly accurately on a big graph. Okay.
Wait.
So
Symmetry is X.
we said that the line of symmetry was x equals -1. We said that the vertex was -1, comma 2. Okay, that's good. We said that the y-intercept was at 0, comma 3. I don't know. I think we got enough stuff to graph this. So first,
Sure. What's the line of symmetry?
and we also said it opens up. So what I'm gonna do is x equals -1. I'm gonna draw
Go.
my y-intercept. Okay. So this is x equals -1.
Negative C.
Okay, so that's my line of symmetry. Okay, now let's plot some of these points. -1, comma 2, so -1, comma 2, that's my vertex. Oh, lastly, we said it was going to open up because A was greater than 0, or actually A was 1.
Wait, is that red dot the vertex?
Yeah, oh, I put it in the wrong spot, didn't I? So I'm going to go to the left 1 and down 2, right?
No, up to.
Oh, yeah. Oh, yeah, you're right. It's kind of hard to talk and graph and all that stuff. Okay? Now, where is the y-intercept? 0, 3, right? So let's write this out. This is the vertex, right? And that occurs at -1, comma 2. This is the y-intercept, and that occurs at 0, comma 3. And then we have our line of symmetry, and we know that it opens up. So over here, now we would know that it opens up just based by the lines. Now earlier you asked a question about how do I know how to put this dot here? Well, how many units do I move from that dot to the line of symmetry?
You
1.
just use your brain.
So you just do it the other way. Now, I could sketch this, and it should kind of come down like this. And that's pretty much it. Okay? Now, let's double check it and make sure. So if I come in here and I clear this out, we had x squared. What was the b term?
Plus 2x.
Plus 2x
Plus 3.
plus 3. Right? Now if we graph it, we should get, yep,
Oh, man, with the vacancies.
kind of the same thing.
Yeah, kind of.
Well, Mr. Adams just sketched it by hand.
Oh, you actually want that.
I just sketched it by hand.
Wait, can we go over how to find like the minimum value?
Oh, so one last thing. The vertex, I'm glad that you brought that up because I did kind of I did kind of go past, I didn't say it. This is the vertex.
Okay.
Now, because it opens up, this is the absolute minimum y value. So when we talk about minimum and maximums, we're always referring to the y values. Well, what is the lowest y value? 2. So the minimum y value in this blue line will be 2. Let me rephrase that. Will y of the blue curve ever equal -5?
Nope. No.
It can't. It won't. Okay? It just cannot do it.
Wait, minimum value can't.
The minimum y value for this graph is
The
2.
minimum y value for this graph can be... So now, if I were to ask you what is the domain, if I ask you the domain, there's no domain restriction on the function. It will be all real numbers, right?
Yeah.
But if I asked you the range, and I know that I have a minimum, what is the minimum of the range?
All numbers greater than
or equal to
2.
Or you could write it like this. You could say, and you can include 2. So you would say 2, comma, to infinity.
Wow.
Oh, I remember.
Right?
Just do the.
I thought right.
Or you could say y greater than or equal to 2.
Yeah.
So what would be the maximum value?
Infinity.
Oh, just infinity.
Infinity.
If it opens
Oh.
Now, if it opened down, so the question is,
Future brownie.
what about What about the maximum value? Well, if a was negative, right? If a was less than 0 or a equaled some negative value,
Why can't
then my parabola would open down, and this would still be the vertex, but you can kind of see that the vertex, this would be what we would call a maximum value.
Why can't be higher?
So the
Why
minimum-
can't be higher
minimum
than
would be unlimited.
Huh?
Minimum would be infinite.
Yeah.
On that
Oh, a negative infinity. Yeah, so he was saying the minimum of this would be negative infinity. Yeah,
Okay.
in the y direction, yep.
Okay.
Still all real numbers because there's no domain restrictions. The only domain restrictions that we ever have to worry about is we can't take negative square roots and we can't have a 0 in the denominator of a fraction. So if I have a fraction as my function and there's something that makes the denominator equal 0, then we have an issue with the domain. If I take the square root of something, there might be an x value that gives me a negative number under the square root. Other than that, most other functions have all real numbers for the domain. Does that make sense?
Yep.
Okay, good. I think we've got one more example and then we're pretty much done.